This video is a continuation of the first PERT problem I started on. So in that video, we calculated that our standard deviation was 3.9 and our expected duration or completion is 31. So now we want to work on our probabilities here. We want to know what is the probability that we'll complete in less than 35 weeks. Well, we know that 35 weeks is more than 31. So that we know that that would be a greater than 50% chance. So we should always check our numbers, make sure they make sense. This is the formula we'll be using. So X is the value we want to know about, right? So this is going to be 35 weeks. Expected completion is 31 divided by 3.972. So then the numerator is just going to be 4 divided by 3.972. This is my z-score. So then, to turn z-score into probability, we use, norm s dist. Use the norm s dist function of our z-score, and we always use this in true for cumulative probability. So the probability of being complete in 35 weeks is 84%. In probability that completing in more than, right? So if it's less than 35 weeks, there's an 84% probability. And if it's more than, it's just 1 minus my probability. And this is my probability of greater than 35 weeks. So for my next one, we want probability in less than 28 weeks. So 28 weeks is less than 31, so we expect that is going to be less than 50%. So my numerator is going to be now -3 divided by 3.972. So this is my z-score. We use the same function here, norm s dist of my z-score and true. So now my probability of less than 28 weeks is 22%. So again, that's less than 50% on this earlier one, right? We were talking about greater than our expected. On this one, it's less than expected. So we're going to have less than a 50% chance on this one and a greater than 50% chance on that one. So this one takes a little more thinking here. We're going to use some algebra. So we want an 80% probability of being complete on time. How many weeks before our due date do we need to start? Well, we can fill in what we know. We know my expected, we know my standard dev, we don't know the z-score, but we can come up with z-score. So we're going to use our 80% probability, 0.8, and this time we're going to use norm S-inv of the probability, and if this is our probability, this is our z-score. So now we can replace the z-score with that value, and then we just use some algebra. So we have this value, and then we're going to multiply it times the 3.972, right? And now, so what we're going to end up with is just x minus 31 equals this plus 31. And so we should start we should start 34 weeks before the due date. And this would make sense because at 31%, we are 50 at 31 weeks, we are 50%, we have 50% probability of completing on time. And so if we want to move up to an 80% probability, we should start sooner, right? So we should start 34 weeks before that due date. If we start 31 weeks before our due date, there's a 50% chance. If we want an 80% probability, we should start 34.34 weeks before our due date. And then for this one, we want the probability that we'll complete between 30 and 36 weeks. So on my first one, we have -1 divided by 3.972. For the next one, we have 5 5 divided by 3.972, and these are my two z-scores. So this is my z-score of less than 30, or a z-score of 30, and this is my z-score of 36. So what I'm going to do is I'm going to take my probability of 36, so equals norm s norm s dist, z-score true. So I know there's an 80% chance that I'm done before my 36th week. Now, I know there's a 40% chance that I'm done before my 30th week. So what I do for the area between the two of those, I'm simply going to take this value minus this value, and this is for between 30 and 36 weeks. There you go.